Good morning, everybody. Um, so, simplifying rational expressions is such an important topic to know, and you really won't be able to move on with our work with rational expressions until you know how to simplify them with factoring. So, I decided that today we're going to take another day to go over it. And since we only did 2 problems on the last assignment, I have another 2 problems for you today, and I'm going to do 2 problems to provide you with further examples and reminder of what we're doing. So, I'm just going to jump into it. I don't need to give a whole intro because I already did that. But let's go for it. What I found last video was that you can't see my plus signs very easily. They look like minuses, so hopefully that helps. Okay, so 4x to the fourth plus 8x cubed over x squared minus 4. So remember, we've got 3 kinds of factoring. We've got GCF, we've got difference of squares, and that's the one that looks like x squared minus g squared factors to x plus g, x minus g. And then we've got the x method, which we use for x squared plus bx plus c. So we've got our 3 methods of factoring. Now, if you recall, we basically do process of elimination. We check for whether there's something that looks like this. We check for whether there's something that looks like this. And if there's neither of them, then we assume it's GCF. So we check the numerator and the denominator separately. So the numerator, right, top of the fraction, 4x to the fourth plus 8x cubed. So is there something that looks like x squared plus bx plus c? No, everything is x to the fourth or x cubed. There's no x squared. Here's another x squared minus, this is supposed to be a number. Again, we don't have any x squared here. So I'm going to say this is a GCF one. Now here we've got x squared minus 4. The x method, we've got an x squared, but we don't have any b. There's nothing with just x in here. Okay? Difference of squares is x squared minus number. That's what looks right to me, especially if you know that 4 is a perfect square. So this one I'm going to label difference of squares. Okay? So now we got to get to factoring. So greatest common factor, 4x to the fourth plus 8x cubed. That's where we'll start writing out. We've got first term and second term. So x to the fourth is 4 x's, x times x times x times x. X cubed is 3 x's. All right, so do they each have at least 1 x? Yes. Each have at least 2 x's? Yes. Each have at least 3 x's? Yes. Each have at least 4 x's? No. So this x is left because there's no 4th x to match it up with down here. Next, you got to compare 4 and 8. So factors of 4, 1 and 4, and 2 and 2. So 2. Factors of 8, 1 and 8, and 2 and 4. So they have all those factors in common, but we only care about the biggest one, which is 4. So here where we already have 4, we're good. Here we want to have 4. But we know that the entire value here should be 8. So you got to say, what do I multiply 4 by to make 8? 2. So now this has the same value as it did before, 8, but we can also see our 4. And now that we can see our 4, we see that we have another factor here. Okay, so if we factor all this out, we've got 4 and 3 x's, so x cubed. And then in the parentheses, we have whatever's left. For the first term, we've got x. We're going to put a plus between them because we have a plus here. And the second term, we've got 2. Okay. Difference of squares, x squared minus 4. So first thing we've got to do to factor this is figure out what 4 is the perfect square of. So square root of 4, or what times itself is 4, is 2. X squared minus 2 squared. Because 2 squared is 4. 2 times itself, 2 times 2 is 4. So x squared minus 2 squared is what we're looking at here. Squared minus 2 squared. So 2 is our g. So our factors would be x plus our g, which is 2, and x minus our g, which is 2. X plus 2 times x minus 2. Okay? All right. So now that we've got this completely factored out, we need to cancel out anything that's on the top and the bottom. So I see x plus 2. Okay? So on top, we've still got 4x cubed. And on bottom, we've got x minus 2. That cannot be simplified anymore. We can't cancel out the x's because it's attached to this minus. And you can only cancel out top and bottom if it's being multiplied. This isn't being multiplied, it's being subtracted. So that's the answer to that one. Yay. Okay. All right. Okay. So let's figure out what kind of factoring we're doing here. So the numerator is x squared minus 4x plus 3. So, start at the bottom, x method, x squared plus bx plus c. That looks pretty similar, right? We've got an x squared, a number with an x, and a constant. X squared, number with an x, constant. So I'm going to call this x method. Make a note of that. 5x squared minus 5x. So this has 5x squared minus 5x, but it doesn't have a constant. This almost looks like an x method, but it doesn't have our constant. So it can't be x method. X squared minus g squared. Again, this almost looks like it. We've got our x squared and we've got our minus, but this is not a number. A number by itself, a constant. G squared is supposed to be a constant, right? 4, 9, 16, 25. This has an x in it, which is not allowed for difference of squares. So it can't be difference of squares. So that leaves GCF. Okay. So, x method, x squared minus 4x plus 3. We gotta do this thing. So, our c is what we multiply to. So c is 3, right? The last number, the constant. We add to b, which is going to be our middle number. So now we're coming up with all the possible ways to make 3. This is easy. 3 is a prime number. 1 and 3 is the only way. But wait, 1 plus 3 does not equal negative 4. That's because, remember, if you have a negative b and a positive c, both of these have to be negative. So, -1 times -3 is +3, and -1 plus -3 is -4. Okay, so don't forget that. Negative b, positive c, both your missing numbers will be negative. So if these are our missing numbers, then when I factor, I've got x minus 1 and x minus 3 for this. Right? Okay, GCF, 5x squared minus 5x. So we got two terms here, 5x squared, which is 5 times x, and 5x, which is 5 times x. So they both have 1x. They do not both have 2 x's. This one doesn't have a second x, so that stays. Now we compare the numbers normally, but these are already the same number, so that makes it easy. Boom. So 5x is what factors out. On the top, we've still got x. We're going to do minus, because you have a minus right there. On the bottom, we factored out everything. So what we've learned in a few different places at this point is that when you've canceled out everything, you put a 1. Remember how we learned last time that if you canceled out everything in the numerator, then you would put a 1? There's another place, cancel out everything, factor out everything, you're going to put a 1. Okay? So, if you factor out everything, there's still a 1 there, because it's 5x times 1 is 5x. So, now that we've got that taken care of, what can we cancel out on top and on bottom here? X minus 1. So on top, we've got x minus 3, and on bottom, we've got 5x. So those are 2 more problems, and hopefully we can get really good at this simplifying thing.